Hi, I'm Keshav Murthy, VP of R&D at Couchbase. I've worked in database R&D from Sybase to Couchbase. For the past 5 years, I've worked at Couchbase R&D. Today, I'm going to talk about new features in Nickel in our upcoming release. It's been 5 years since we released Nickel in our query service. Today, thousands of enterprises, community users, and applications use Nickel, and they have successfully developed and deployed applications in production. Thank you. First, I'm going to be giving a brief background on Nickel and its motivation. Then we'll get into the details of new features in our upcoming release. So Nickel so far. The goal of Nickel is to give developers and enterprises an expressive, powerful, and a complete language for querying, transforming, and manipulating JSON data. It is SQL for JSON. Nickel has DMLs, select and delete, insert and merge, update and upsert. It has DDLs, create and drop to manage its indexes, DCLs, grant and revoke to manage its permissions. In its queries, it supports select, join, project operations, grouping and aggregations, scalar functions, and window functions. It is supported by high performance indexes in GSI. We've even found a way to push its performance further by exploiting the inverted indexes in our full text search. Using Nickel in your applications or by developers or DBAs means you are improving the productivity of respective people. Nickel is designed to improve the productivity of everyone who uses it. Nickel is implemented by two of our services in Couchbase, the analytics service and the query service. Analytics service is designed to analyze large amounts of JSON data and give you insights quickly. Majority of the workload is select statement. Query service is designed to help you develop and operate modern applications faster and better. For the rest of the talk, when I say Nickel, I mean Nickel implemented in the query service. There are 4 wonderful talks focused on analytics. Please check them out for the details on improvements and the details of analytics service in Couchbase. On to Nickel. The common question I get is, if Nickel is SQL for JSON, how does it compare? So here is my answer. Nickel walks like SQL, quacks like SQL. It is, after all, SQL for JSON. When developers see Nickel, that's the first reaction. It is SQL. SQL, of course, is vast. It's easy to get started and learn. It's a bit difficult to implement in a distributed database, just a little bit, but developers simply write the queries, they're good. As you can see, Nickel compares well with SQL in terms of objects, the statements, the approaches to the optimizer, the indexes, data types. SQL, of course, has rich data types. Nickel has JSON data type. We have a lot of conversion functions to help you navigate and manage all the different data types you require. And of course, we'll talk about transactions in a moment. We have always had NoSQL industry's best declarative query language implementation, period. We have docs, blogs, and books describing all of these features and statements and Nickel in gory detail. I won't take up the next 10 hours describing each of these features. Suffice to say that coverage in Nickel for SQL features is far, wide, and deep. I will focus on the features in our upcoming release. we are introducing scopes and collections for your data management. We have introduced the cost-based optimizer, extended the functionality in GSI indexes to support the new collections, the flex indexed to improve the performance of your queries, the new features like user-defined functions, both Nickel and JavaScript, the index advisor, as well as transactional support in Nickel. So let's get into the details. Here is the summary of what I'm going to cover. Let's get into features one by one. On to collections for Nickel. Prior to this release, you could insert a document into the bucket. That continues to be so. Bucket is used for resource management as well as a container. Starting with the next release, we're introducing two new concepts, scopes and collections. Each bucket will contain one or more logical scopes. Each scope contains one or more collections and UDFs. A cluster contains many buckets. A bucket contains many scopes. A scope contains many collections and UDFs. In Nickel, use the collection as a key space reference. Previously, you used a bucket as a reference. Now you can use collection as a reference. Since the collection has to be referred with bucket.scope.collection, you can use query context for shorter reference. The new implementation of scopes and collections is fully compatible with the previous applications and previous queries. When you simply refer to a bucket, all the operations happen on the _default scope and default collection. Here is an example of a bucket cxprof that contains 4 scopes, the USA, UK, EU, and the default scope. The scope USA contains 2 collections, profile and log info, and 2 UDFs, foo and foo2. We'll be talking about UDFs in a moment. Within your query, in the from clause, you reference the collection with cxprof.usa.loginfo. And then the rest of the query looks and feels the same. And you create an index on cxprof.usa.loginfo. So that's how you refer to the specific collection. The rest of the index creation and management remains the same. So the introduction of scopes and collections means we have had to extend Nickel, all of the Nickel DMLs and all of the Nickel DDLs to support collections. So all the object reference, wherever you had reference to the bucket, now also support reference to the scopes and collections. That's true of all the DMLs as well as DDLs. The fully qualified support, the fully qualified path is bucket.scope.collection, or you can use the relative path using the query context. The access control statements, grant and revoke, support both of the bucket as well as the scope and collection within the statements. Indexes can be created on specific collections. Index names just have to be unique per collection. In the next release, Couchbase is going to support up to 1,000 collections plus per cluster, as well as 10,000 indexes in a cluster. Here's an example of creating the scopes and collections. By the way, use still create the buckets using CLI or REST API or using the web console. And from then onwards, you can create scopes and collections with the nickel statements. And once you create the collection, you create any number of indexes on each of the collections. And here's an example of create index statements on the two collections, cxprof.uk.users and cxprof.uk.royals. And there's an example of function that can be created under this specific scope, and example of how to invoke this get users function from a select statement. On to language features. Ever since Sybase introduced T-SQL stored procedures, every database has supported user-defined functions in various languages and to various degrees. Some to improve developer productivity, others to add business logic or compute closer to the data, and some others to extend the database functionality itself. Our purpose of introducing UDFs in Nickel is to improve developer productivity. Commonly used queries or logic can simply be defined inside the bucket and invoked by the developers with the right parameters. We introduce 3 new statements: create, execute, and drop function. Once the function is defined, it can be invoked in any of the DMLs. Each function has 0 or more parameters and return values. Each function is executed on the same node in which the statement is executed. As you know, in Couchbase, you can have 1 or more query nodes. Each query node can execute possibly thousands of statements concurrently. What we are saying is that statement and all of its UDFs within this statement are executed on respective query nodes. All of these functions have to be created under a scope. There's of course a default scope, and while these statements or while these functions can be invoked with execute function or any DMLs, they cannot be used as a key to the index. Only built-in scalars and array functions are used. User-defined functions are not yet supported in the create index statement. Here we have examples of UDFs defined in the Nickel language itself. These functions have to be defined with a single Nickel statement. This can contain only one statement. Each of the statement can be pretty complex, but it's still one single statement. As you can see here, it's a select statement for the function get users. And then the second function, volume, is simply an expression that's returned. It's a compute expression that's conforms to the Nickel query expression. Once it's defined, here we have an example of insert statement that invokes the volume and in the projection of a select statement. Then we have a select statement which uses the volume in its wait clause, and finally a execute function that directly executes the function volume. Second type of user-defined function is JavaScript functions. JSON came from JavaScript, so it's natural that you want to manipulate JSON within JavaScript. First, you need to write the JavaScript function itself, then add that into the library. Once you add the function into the library, then you create the function within your scope using the create function statement. Once this is defined, then it looks and feels like a standard nickel UDF that can be invoked in any DML. You do have to take care to match the number of parameters for the function. In this example, we have a JSAD, which takes 2 parameters. If you invoke it with 2 parameters, it all works fine. If you do invoke it with 3 parameters, you do get this 10104 error saying incorrect number of arguments supplied. To execute this JavaScript function, each query node has a built-in V8 JavaScript engine. So because there's a change of context from nickel to JavaScript, at minimum, each JavaScript invocation takes about 8 milliseconds in my testing. So there is overhead to calling this. So that means you have to do something substantial in this JavaScript more than just adding 2 numbers like I've shown here. Each function name has to be unique within the scope, whether they are a nickel function or a JavaScript function, it doesn't matter. Right now we support up to 500 functions. This is a number we expect to increase as we go further. So let's say you have larger JavaScript function. You can store the JavaScript code itself in a file, and then you register that function into a nickel library using curl, as I've shown here. Once you add it to the library, you simply create the function and invoke it as usual. Everything else remains the same. You do have to make sure these functions are self-contained. The globals are not yet supported because this function itself can be in the state of execution multiple times within the same statement. So sharing globals requires other complexity we don't yet support right now. On to the optimizer features. Why do we need a cost-based optimizer? Currently, we have rule-based optimizer that comes up with a plan based on set of rules. The cost-based optimizer takes cost into account. Here's the analogy. If you have a rule-based routing, from when you ask it the route from one place to the other, it always goes by a certain set of rules, and no matter what the current traffic is, it always reliably generates the same plan or same route. Here it takes the rule-based routing, it takes 32 minutes. In case of cost-based routing, it has the estimate of the cost in each route or each subsection. Those are all the access paths. And then it knows how to use these costs to calculate the cost of each route and come up with the best route possible with respect to time here. So that's the difference. Cost-based optimizer takes the cost of each access path into account, consider all the access path, and comes up with the best plan possible for your queries. Here is the life of a query when it goes through the nickel query engine. Given a nickel statement, it goes to parsing, semantic analysis, and the rule-based optimizer takes this analyzed tree and uses all the metadata within the system, what collections it has, what indexes are defined, and based on the rules comes up with a query execution tree, which is then executed. What does a cost-based optimizer do? We have added the ability for the system to collect new types of statistics. So in addition to the metadata available, it uses the additional statistics about the data and chooses the best available access path to come up with a better plan. Since for JSON data, schema is flexible, we had to extend the concepts from Pat Salinger's cost-based optimizer approach to adopt to the JSON world with the flexible schema, and where the not only the schema is flexible, but the type of the data can change from document to document. So this is a patent pending work from Couchbase that offers a differentiated optimizer for you. So let's look into details of what this optimizer does. What is a typical optimizer does? And that's true of Nickel optimizer as well. First, it looks to rewrite the query so that it can be optimized better given the capabilities of the optimizer. Then it does index selection if the indexes are available for each of the collections it has to access. So for that, it not only has to select the right index, it has to decide which predicates are pushed down to the index scan level. Within Couchbase Nickel optimizer, we also consider aggregates that can be pushed down, also pagination constants that can be pushed down, like the limit and offset that can be pushed down to the index scan as well. And in the rule-based optimizer, these were done based on rules. Here, cost-based optimizer considers the cost of pushing down the each predicate, and it selects the index where we can maximize the use of for the index for the predicate push down as well as the aggregate push down. The third that the optimizer decides is if you have a join specified in your query, it has to decide whether it uses the nested loop or the hash join implementation. For certain types of queries, nested loop is better. For queries with larger amounts of data processing, and if it qualifies for a hash join, you need to have an equality predicate for it to qualify for a hash join, so it considers that as well. Then for each join, it has to decide which collection or a subquery forms the inner or the outer side of the nested loop. And similarly for hash join, it has to decide which side has to be the build, which side has to be the probe. It has to decide all this for all the collections or for the access paths. So these, even with a small number of collections and indexes, the combinations it has to consider can be huge. And that's what the optimizer does. So it considers the cost of each and comes up with overall the query plan with a minimal amount of cost that translates well to minimum amount of time and resources used by the query to execute and give you the results. So I talked about cost. This cost is calculated not only knowing the access path cost, but also the statistics about the data. Right? The data from California can be skewed to one type of product, and the data from a different state can have a different skew. So depending on what you're querying, so we want to choose the right access path. So that's why we have introduced a new statement called update statistics. This update statistics collects statistical data. That means the frequency, number of distinct values, and it creates a histogram based on all these values, and that histogram is used to calculate the cost. Eventually, we actually calculate the selectivities and cardinalities for each of the predicates, and then calculate the overall cost of the access path and the plan itself. In this update statistic statement, you give the field names for which you have the you've used them as index keys. The order here doesn't matter. Unlike a create index statement, the order of the fields in the update stats, it doesn't matter. It's all the same, and you can combine them so that these update statistics just have to sample and sort once. When you have when you don't have any statistics collected for a field, we use rule-based optimizer for the query. And of course, for 7.0, we have enhanced advice statement to recommend the statistics to be collected for a better query plan as well. So here's an example of explain plan. Actually, this is a profile which shows what was estimated and what was the cost. So here, cardinality of the for this scan was 128,068. The actual items that qualified was 168,168. So this delta between estimates versus the reality, that's always the case. But the idea is you can see that just the cardinality and the cost itself in your simple explain plan, but when you see the profile, you actually see what was estimated and what actually was the real number of items that qualified for the particular predicate. So despite all these improvements, you can still use the use index and use hash if you want to override the decisions of the optimizers. So that option to manually tune the queries continues to be there. Okay. In 6.5, we previewed our index advisor, and we GA'd the advice statement in 6.6. So basically, if you prefix a select statement with advice, we'll come up with the optimal index you need to have to execute this particular query. So the advice takes a single statement. Advisor can take multiple statements, or it can even monitor a workload for certain duration and come up with a best statement, best set of indexes for you to create. It can also take the result of completed requests and give you the advice as well. So this is advice has been there in 6.6. In the next release, advisor is going to go GA. What we have done for both of these facilities is to enhance it to take the sampling of the data, understand how the cost-based optimizer does, and made the advice even more optimal, so that what we recommend as part of this advice works well with the cost-based optimizer. And it also gives the advice on what statistics to collect by generating not only the index advice for covering and non-covering index, but also the update statistics statement itself. As usual, we look forward for you to using this. This has been one of the most popular features in 6.5. So we look forward to your feedback as well. And we have also provided this as a service in at index-advisor.couchbase.com. So you can simply use this service, give your queries, and you'll get a recommendation. Of course, we don't have your data, we can't sample and give you the recommendation that's optimized or highly optimized for a cost-based optimizer, but yeah, it gives you the recommendation based on rules, but recommendation based on rules is still better than your the normal guesswork. Now, for a quick view of the indexing improvements. The main improvement is indexes can now be created per collection. We support up to 1,000 collections. That means number of indexes have to be 10x that much. So a cluster can contain up to 10,000 indexes if you like. There is significant improvement in both the performance and resource usage to make this happen, both at the GSI layer as well as our Plasma storage engine. So when you create this many indexes, finding the right name can be challenging. So that's why we have made the index names only have to be unique per collection. All the different features of indexing, partial indexes, expression-based keys, partial indexes on collection with multiple types of documents, all these things continue to be supported. But instead of just creating on the bucket, you now create on specific collections. As I said before, we will support large number of indexes, and once you have that, the tooling, the query, the optimizer, the explain, the statistics, all those will support indexes that are created on specific collection. There's a separate session focused on indexes, GSI in particular. Please check that out for more details. Again, quick view of the search features that in the upcoming release. Just like GSI, FTS also allows creating indexes on specific collection. Both in the UI and in the definition, you have a chance to specify the specific collection on which you want to create indexes on. Because we have search capability, and search tends to have a slightly different use case than a typical GSI. In FTS index, not only you can create FTS indexes on specific collection, you can also create FTS indexes, a single index on multiple collection. So when in this example, I have one index created on collection profile. I have other index, single index created on both game info and log info. That means when you search for a value within the FTS index, you will get answers with the documents both in the game info and log info. And of course, when you get the result, we'll also prefix the result with specific collection name so that you know which collection specific results came from. Rest of the features on this FTS indexes, whether it is a search functionality from Nickel, Flex Index that we introduced in 6.6, they continue to work seamlessly, as well as the direct query from the on the FTS index itself. Okay, Flex Index. This is a functionality that we introduced in Couchbase 6.6, but I think its capability is significant enough. It is worth emphasizing again. The Flex Index allows the query service to leverage both the search capabilities as well as additional performance optimizations using the search index on standard nickel, right? It improves the query performance of the ad hoc queries, because for many of the reporting applications, the patterns in which the queries are generated is not predetermined. User determines what predicates, what grouping, what ordering. So when the nature of the predicates are not predictable, the capabilities within the search index, because search stores and orders and process the index differently, it's highly suited for the cases where the patterns are not predictable. And this is a feature that we have in 6.6 itself. This allows the applications to leverage the unique capability of keyword analyzer. That means when you create a FTS index, you have to use a specific analyzer called keyword analyzer. Normally, when you create a FTS index, it stems the words into its root words and indexes them. That's how it does the fuzzy searching, relevance-based searching. In this case, when we say keyword analyzer, it stores the values as is and indexes them. So for the range predicate, we want the values to be stored as is, just like how we store it in a GSI index. And because of the inverted tree structure and how the queries processed using the dynamic bitmap layer within the FTS, a query that looks like this, right? Select star from CRM, where you have a complex ANDs of ORs queries here, and any of the query that you create or our own advisor recommends for this particular query is not going to be as efficient as a FTS index. And when the FTS, in this case, you do have to use the use index directive to specify that you want to use the FTS index for this query. And when the query successfully uses the FTS index, you see the index FTS search as a stage within the query plan. Of course, we haven't enhanced the cost-based optimizer to use this explicitly. That's why you need the use index predicate. That's improving that is in our plans as well. Finally, distributed nickel transactions. As they say, 6,000 years ago, the Sumerians invented writing for transaction processing. NoSQL database themselves have gone through their evolution. NoSQL originally meant no SQL, no transactions for multi-statement, multi-document transactions. So we have gone through our evolution to, you have seen support of SQL before. Now we are adding support for transactions. So what does nickel transaction mean? Nickel transactions ensures database consistency when multiple data modifications are performed on multiple documents in multiple collections, multiple scopes, multiple buckets with multiple nickel statements. It's multi-everything, as I said before. The nickel transactions coexist with and interoperable with concurrent transactions with SDKs that were introduced in 6.5. Nickel transactions ensure data integrity for application transactions, which require multiple operations in a concurrent environment. All the DML operations are supported within the nickel transactions. We use optimistic concurrency, and also the design of this is so that there are no central coordinators. That means you can issue transactions on query nodes. There is no need to configure anything new to use transactions. It's available by SDKs, CBQ shell, REST API. We'll talk more about the ACID properties of the transactions in a moment. So let me just describe to you how Nickel transactions work briefly. You start the transactions by issuing the begin transaction statement. And now the first update statement goes and, in this first statement, you say, okay, update customers at balance equals balance plus 100, where customer ID equals 4872. So there's a wait clause. Let's assume there's an index on CID. It does a scan of the index, gets the document ID that matches the customer, goes ahead and gets the qualified document to the Nickel, and updates the document in memory. So far, the process is same whether you are using update statement outside the transaction or inside the transaction. Now, what happens is when you update the after Nickel updates the document, we do not write it back to the KV. This is what we call the read phase. We go ahead and read the document and cache it in our internal data structure within the Nickel. Now, second update comes in. Again, it's updating the customer document. It does an index scan, and here it's a different customer ID. It possibly gets a different document ID. It goes ahead and gets the document, updates it, again keeps in the cache. Okay, two different documents, two different customer IDs, fine. Now comes an interesting situation where you have select statement on customer, and then customer ID is the two document IDs that you just updated. What happens now? It goes and does the index scan, gets the two qualified documents. Then, before it goes ahead and fetches the document from the KV, it checks to make sure, hey, are these documents something that I have updated in the current transaction? Of course, because we have cached it, so these documents are in our cache. So then it gets the latest values, that means the updated values within the current transaction, and sends it back to the application. This is how it achieves this level of consistency and read your own writes. And also this helps in the cumulative effect. Let's say within the same transaction, you updated the same customer multiple times, so you get the cumulative effect. Once we fetch the document from the KV and update it within the transaction, that image is used for cumulative updates or any projections within the transaction. And then once you do all these updates, then you finally commit. And this is where we have these changes cached in our internal structures within query, and then we start to write back into the KV. Of course, just like how we verify whether the version between the version we read and cached to the version we are writing, has there been any intermediate change to the document we are updating? If in fact there is any change to the document, then the whole transaction is aborted and rolled back, and the customer or the application will have to reissue the transaction and retry this whole set of application. So that's the basic idea. From the begin work to commit work, till commit happens, we follow this optimistic concurrency model, and then during commit, we go ahead and write it. there are a lot of additional details in terms of the how this is done efficiently, effectively, without a central coordinator. That's why we have a patent pending. But I'll get into a little bit more of the details without boring with all the gory details. Okay, high-level view of what are all the asset guarantees that the nickel transaction provides. Atomic, that means if you commit, it stays committed. If the application abandons the transaction for any reason, it's we still follow the presumed abort protocol. That means the transaction is deemed aborted. If you issue the commit and it didn't come back to you with the confirmation, it is also deemed to be aborted as well. Consistent, all the modifications are done on a qualified set. So this is updates are still based on the same set theory that the transactions in relational systems does as well. So in terms of the consistency, the only constraints in Couchbase is the unique key constraint and the document key, and that's still applied within the nickel transaction. We avoid the Halloween problem because the index scans, once it started, we do the scan on a snapshot. Any subsequent updates do not reflect in the current snapshot. That's why we avoid the Halloween problem altogether. In terms of isolation, we support the committed read isolation. That means all the data that we read from the index is all data that was committed. All the reads that we read from the KB is also committed read. And of course, we also support read your own writes. That means if you have updated a document within a transaction, so you get the latest version of the value within the transaction. So that's still considered the right thing to do within the read committed isolation. All the reads are monotonic, atomic. That means you will never read a dirty read. You could read something that was committed as part of a transaction, but you may not see all of the changes at once. But you still see only the data that was committed. By default, the index scan consistency is request plus. If you have extreme performance need, you can change it to unbounded reads of the index. So we don't do any dirty reads, and we don't have an option for you to change the isolation to uncommitted read or dirty read. It's always read committed isolation. Durability, we support multiple durability options. Majority is default. That means in a cluster, when you write, we send the updates to majority of the KB nodes, and if it is sent, it is in the respective cache of the majority of nodes. Then we deemed it as that's one of the durability options. If you want the writes to go into majority of the nodes and persist on all the active nodes, that's another durability option. Persist to majority is yet another durability option where you ensure all the data that you committed are persisted in the majority of the replicas. So that's how we support the ACID semantics within the nickel transactions. And like I said before, this transactions is available through all the SDK as well as a CBQ shell and query workbench. One of the salient things about this is, like I mentioned before, the query service is designed to enable interactive applications. That means we expect short running queries making a few changes. One of the requirements which SDKs will automatically take care is each transaction, once you do the begin work until a commit or rollback is done, all of the statements for that particular transaction is sent to the same query node. Right? You can have multiple transactions running in a query node. You can have multiple query nodes running independent transactions. But each transaction from begin work until a commit or a rollback is done, all of the statements are sent to the very same query node. If a query node is taken off or disappears in between, of course, all of the transactions are presumed to be abort, and applications will get an error and they'll have to retry the transaction. Okay. Within the nickel, as you saw, there are a lot of statements. Which of these statements are acidic? So begin transaction. When you send a begin transaction request to any of the query nodes, it returns a transaction ID. Then it's the requirement of the SDK or the tool to send all the subsequent statement for the transaction to the exact same query node. And when it sends the statement, it also has to send the transaction ID as a parameter to the statement. Remember, underneath query is communicating with the SDKs and others, not through a Persist connection, but through REST API. And each REST API is an independent request, but the way we tie in all the different statements of a single transaction to bash them and to commit a rollback is making sure we send and reuse the same transaction ID that was returned by the begin transaction with all the subsequent statement until a commit or a rollback. All the DMLs are supported within begin work to commit. So that means select, insert, update, delete, upsert, and merge. If you issue any non-DMLs like the create index, alter index with the transaction ID attached, you will get an error. Now, when I insert or update that the application issued within the transaction fails, we simply roll back that statement, but the transaction still is open until a commit or a rollback is issued. We support save points. You can set any number of save points within the transaction. You can roll back to a save point after it has been declared until a commit or a rollback transaction is issued. Rollback transaction rolls back the entire transaction, and commits all the modifications to the Couchbase data store. If there is any failure at the commit, the whole transaction is rolled back automatically. Okay, that was all multi-statement, multi-collection transaction. And the idea there is you'll have large number of transactions. Each of them are doing small amount of work, like the examples you saw before. But there are cases, for example, in ETL queries, where you would want to update thousands or tens of thousands of document within a single statement. In fact, this is one of the feedback for our 6.5 transaction feature from customers. So in the previous approach, like I said, when we do any modifications to support the read-your-own writes, statement level atomicity, and so forth, we cache the changes that you have done within the transaction until the transaction is committed. Now, if we start caching tens of thousands of documents within the query, that can be memory consuming and can lead to several resource management issues. So when you want to update large number of documents and can express that operation as a single nickel statement, simply set the parameter is tx implicit to true. So that means this particular statement will be run under the auspices of implicit transaction. So that means we implicitly open a transaction for all the data modifications. We go through the same procedure as before, do the index scan, get the document, do the updates, and instead of caching, as we modify the documents, we start to write back. And when we complete modifying all the qualified documents in case of update, then we issue a commit implicitly and it gets committed. You don't have an option to issue multiple statements and all that. So it's simply, and this also provides all the asset guarantees. It's all or nothing, it's durable. You can set rest of the parameters in terms of persist to majority, persist, and majority and persist to active, and all the options are available. But here, the query service automatically updates all the values under the auspices of transaction. In case of a failure, it automatically is rolled back. Use this when you're trying to update large number of documents. And as I said before, each update is staged in this transaction. On any failure, the whole operation is rolled back. You have given examples of updated and insert statements. You can issue any of the DMLs: insert, update, delete, merge, upsert, and pass this tx implicit parameter. Okay, here's an example of SDK support. Here we have the Lambda pattern implemented in Java SDK to support distributed transactions. So to support queries, we simply added another method to this get result. Sorry, to the Lambda. So the method query takes the statements as a parameter and you issue any of the statements. So here I've used the same statements that I've used before before. Simply issue the statement and you get the you can execute the query there. You can mix and match KB and query, and this is an example of Java SDK support for nickel transaction on all the rest of the SDKs is in our roadmap. Nickel transactions best practice. Documents qualified are determined by scanning the index using the scan consistency, and the request plus is the default scan consistency, so that when you commit something, the subsequent transactions see all the changes committed by the previous commit statement or previous transaction. Read your own rights transaction sees its own changes in all the subsequent queries within the transaction, because we cache the changes within that query service. This is one of the reasons why all the statements for a single transaction has to and should go to a particular query node. So our advice is to limit the number of documents that are updated within a multi-statement transaction. The big effect is these updates are cached, it takes memory, and as you cache more and more, the possibility of conflicts get higher and higher. Use single transaction when you need to update large number of documents. All the updates are optimistic. That means we assume there won't be any conflicts when we write, but with optimism we have to be realistic about the real world situation when applications are designed without taking the hot row problem into account. Basically, hot row problem says if all the transactions are trying to update the very same document, then let's say you have 100 transactions trying to update one single customer document, only one will get through, the other 99 will get failure and they have to retry. There is no option for you to wait in the middle of the transaction. They go ahead with the optimistic approach, but then they see there's a conflict between the cache they have versus the cache that was seen during the commit. So you have to design your application to avoid the hot row problem. Don't do any non-transactional writes on the documents participating in the transaction, and this can lead into lots of issues. Multi-statement transactions are lock-free and coordination-free. So that means once you have designed the applications well, once you see the performance on one node, the performance of the system when you add new query nodes should increase in a linear fashion because of the optimistic concurrency approach, and there is no locking, latching, waiting, as well as coordination until the commit phase, where we do the coordination between our transaction, and other transactions, as well as checking for any write-write conflict. Okay, that's my final slide. As I promised before, I've covered the new features that we have added in the upcoming release, and the beta announcement will come out pretty soon. Keep an eye out, and we've added a lot of features in for data management, for stored procedures, the cost-based optimizer, indexing, flex indexing, as well as transactions. Finally, use Nickel and prosper. Thank you.